Hey guys, today our goal is to review all of the vocabulary words for all of these angle pairs that you may remember from previous math classes that have to do with parallel lines that are cut by a transversal, or maybe not parallel lines. And so in this diagram, we're going to start with a pair of lines that are considered parallel, and they have given us a lovely notation at the top. The L with the double line and the M means that L is parallel to M. So I wanted to show you something kind of cool about the angles within these, and I'm sure you already know this, but I don't know if you've ever gotten to see visually how if I were to take this highlighted angle 2 right here and just slide it on down the transversal line, this is the transversal line, until I get to angle 6, check that out. They match exactly. So I could say that angle 2 is congruent to angle 6 because, I mean, it looks like they're the same measurement, but we've also proven it if the lines are parallel. So then, with some more creative twisting and turning here, I can actually rotate angle 6. Oh my goodness. Upside down. I think I went too far. Let's see. And put it right there where angle 7 is. And remember, angle 6 and 7 we already know are congruent from last week because they're vertical angles. So this is kind of just like reiterating the point there. So I can add that angle 7 is congruent to those other angles. And then, of course, I can take this and slide it on back up the transversal line until I get to angle 3, and it matches exactly too. That is super cool. So within this diagram, I have 4 obtuse angles. I don't know what they measure, but I do know that they're all the same size. They're all congruent. And I also have 4 acute angles that are all congruent to each other. Angle 1, 4, 5, and 8 are all the same. So within this picture, I only have 2 different degree measurements for all of the 8 angles if the lines are parallel. Okay, let's examine like what if the lines aren't parallel. Well, in the first picture, I can go back to what I was just talking about where I see 110, 110, 110, and 110. So with those parallel lines, I've got 4 obtuse angles that are congruent. However, if I look over at illustration 2, where line 2 and 3 are clearly not parallel, I see my 100 degrees and my 100 degrees right here because of my vertical angles. So that's going to still apply no matter what. But if I slide on down to line 3 and I look at angle F and angle H, those now measure 110 degrees, which is not the same as 100. So as soon as my lines are not parallel, they're not going to create congruent angles that go from one intersection to the next intersection down that transversal line. So just be careful when we're making assumptions with these, but we still can name a bunch of different pairs of angles with vocabulary words. Let's practice and see what you guys remember. So I've got alternate interior angles. And I think that just to help us remember this, the word alternate means on each side of the transversal line. So if I make that transversal line darker, you can see angle D is on the right side, angle E is on the left side. They're on opposite sides of that transversal. They are also inside of the parallel lines, which is where the word interior comes from. Let's see if I can do a better job over here. Inside of the parallel lines, C and F. Opposite sides of the transversal, but inside. So that would bring us to alternate exterior angles. I think of the word exit, like you're trying to get out, you're trying to get away from those parallel lines. So you're on the outside of the parallel lines, but you can see if you're traveling down that transversal line, they are still on, one's on the right side and one's on the left side, which makes them alternate. Another pair of angles that is similar to these would be the same side interior angles. And I can draw a picture of those really quick. So if I look right here and right here, those 2 purple angles are on the same side of the transversal line. They're both on the right side, but they're on the inside of the parallel lines. So those would be called same side. And there's a couple different vocabulary words for these that you might hear out there, but same side interior is going to be the way that we're going to refer to those today. All right, another vocabulary word that we use with these is corresponding angles. So all of the diagrams here are representing corresponding angles. corresponding is the really neat trick that I showed you where you can grab angle 2 up here from this top intersection and you can slide it on down, maybe if it'll cooperate with me. Yep, there we go. To angle 6 in the second intersection with that other line, and those are going to be called corresponding angles. Now, sometimes they're congruent. In these pictures, they've told us that they're congruent, which must mean that those lines have been parallel. But if the lines are not parallel, we can still name them corresponding. They just aren't necessarily congruent. All right, quiz time. Let's see how much of this you guys remember. So my first question is, what would you call angle 1 and angle 3? Good. Those are vertical angles. What about angle 1 and angle 5? Okay, cool. Those are my corresponding angles. I can take angle 1 and I can slide it on down the transversal to 5. What about angle 3 and angle 5? Cool. Those are called alternate interior angles. So they're on opposite sides of that blue transversal line, and they are inside the parallel lines. Okay, last one. What about angle 1 and angle 7? What would you call those? Awesome. So those are alternate exterior angles on the outside. Okay, a couple more questions. Now, they gave us one of the angles down here, which is 65 degrees. And then they also told us that line K is parallel to line P. So we can make some assumptions about the congruency of different angles. So my first question is, if you know that that angle in the corner is 65 degrees, what is the measurement of angle 7? How could you figure that out? All right, cool. And so that would be 115 degrees. And I know that because 65 degrees and 7 are sitting on the same line. So they make up a linear pair. We know that a linear pair is supplementary. That's all. Awesome review from last week. What about the measurement of angle 3? Good. So since we know that angle 7 and angle 3 are corresponding angles, both in the bottom right corner of the intersection of the transversal to the line, it is also 115 degrees because given the parallel lines, those corresponding angles will be congruent. Last one, what about the measurement of angle 4? Good. So one way to pick this out is just that angle 4 is definitely acute compared to the other two angles that we've looked at. Another way to pick this out might be to label this as 115 degrees right here so that you can see this linear pair again along the line, making angle 4 also 65 degrees. So 65 degrees is correct for the measurement of angle 4. All right, slightly more complicated example here. We're going to uncover even more of this crazy diagram. Couple questions first. Do you think that angle 1 is congruent to angle 7 in this diagram? So that would be yes. And how do you know that those are definitely congruent angles? Okay, good. So those are still called vertical angles, and that's from last week. It doesn't matter if we have parallel lines or where the transversals are or anything like that. Vertical angles are going to be congruent no matter what. What about angle 2 and angle 6? Because I'm looking at line P and line Q here, and I don't think I see parallel lines. So I'm a little nervous about 2 and 6. What do you think? Okay, good. I think I gave it away. That one is a no. So we can still name them with a vocabulary word, even though they're not congruent to each other. Can you tell me what angle 2 and angle 6 would be called? All right, sweet. So angle 2 is on the inside of line P, and angle 6 is on the inside of line Q, and they're traveling down that transversal line R, and they're on opposite sides of that transversal line R. So these are called alternate interior angles. Okay, one more. Not going to give it away this time. What do you think? Is angle 5 congruent to angle 7? All right, and that is also a big fat no. They are going to be called corresponding angles. So if we put those in red, this is the bottom right corner of this intersection of the line with the transversal, and then this is the bottom right corner of the line P with the transversal. However, because P and Q are not parallel, we cannot assume that angle 5 and angle 7 are congruent. And I mean, think about my little trick where I dragged one angle on over to the other one. These don't even look like they're congruent. They don't look the same size. So sometimes you can rely on your visual. Just be careful not to make any assumptions. But since we don't have parallel lines, these are not congruent. Okay, let's unveil the rest of this wonderful picture here, and I have a couple more questions. So the first thing I'm going to do is get all this out of the way that we were already doing so that you're not confused, okay? So what would you call angle 2 and angle 16? But I also want to know, what is that transversal line that you're looking at when you're naming angle 2 and angle 16? Okay, good. So in this picture, the transversal line, is going to be line P. And so angle 2 and angle 16 are going to be called alternate exterior angles. All right, let's try that again. And we're still going to name the vocabulary word and what the transversal line is that you're looking at. So with angle 14 and 16, what would you call those, and what is the transversal line? Okay, good. Angle 14 and angle 16 are corresponding angles. They are both in the bottom left corner of the intersection, bottom left corner of the intersection. And when I'm saying intersection, that transversal line is line S. All right, last one. What would you call angle 5 and angle 11, and what is the transversal line? Okay, so those are called alternate interior angles. They are in between line S and line R, but the transversal line that you're looking down is line Q. Excellent. So remember, be careful when you're talking about congruent angles, especially if they haven't told you that the lines are parallel, but all of our vocabulary words can still be used. All right, it's time to kick this up a notch. Let's have some fun. We've got some expressions here. We get to solve some equations. Got to knock out the basics first, though. So what vocabulary word would describe these angles that are labeled with the expressions? Good. Those are corresponding. Okay, my next question is, because this is going to help us set up our equation, are they congruent to each other, or are they supplementary to each other, or maybe they just don't have any relationship at all? What do you think? Okay, excellent. Now, I don't know if you caught this, but these wonderful little red lines right here, red markings, those tell you that those two lines are parallel. So don't make any assumptions about them being, ta-da, congruent unless you know that those lines are parallel, but they did mark them in the picture for us. Okay, how would you set up an equation to start to solve for x? All right, so from the previous slide, we said that they were congruent to each other, those angles. And so you would set the 17x minus 4 equal to the 12 plus 15x. All right, go to town, solve this equation, tell me what you get for x. All right, so here's some steps that I've shown, and the correct answer is x equals 8. I hope you got it. The hard part should be setting up the equation, and from there you guys are experts at solving. We've been doing a bunch of solving equations. Okay, let's look at an even more tricky one. Now this one has two different variables within all the expressions that they've given me. So they said the measure of angle 6 is 12x plus 13, but then you see the measure of angle 5 is 7y. Well, we need to be really careful then if we're going to try to use angle 6 and angle 5 together when we set up an equation, because if we have x and y, we can't really combine any like terms and solve. So it would be probably a good idea to start with the measure of angle 6 and the measure of angle 2 and set up an equation where we can solve for x first. Then we can go back and talk about how we might solve for y. And then, of course, finally, the end goal here is to find the measure of angle 8. So we'll get to that. All right, look at the diagram, set up an equation, and tell me the vocabulary word that identifies angle 6 and angle 2. All right, awesome. So they are congruent to each other, and they are called corresponding angles. Angle 2 and angle 6 are congruent. Oh no, I didn't tell you that those lines are parallel, and I definitely would have to do that. And so we'll just go ahead and mark it since I forgot and put, let's see, over here by A, we'll put a little arrow, and by B, put a little arrow. Okay, so now that we know that they are parallel, we can go ahead and solve the equation. Sorry about that. So 12x plus 13 equals 14x minus 9. Ready, go. What's the answer for x? Okay, awesome. So again, just kind of showing the steps that I set up there really quick so that you can check your answer. And x is equal to 11. So unfortunately, that doesn't, other than solving for x, that doesn't really help me get any closer to my measurement for angle 8 because 11 is not a measurement of any of the angles in this picture. It's just representing the value of x. So let's say that I did want to go back and figure out, for example, the measurement of angle 6. Because if I knew exactly what the measurement of angle 6 right here is, then I could think about the measurement of angle 5 because that is making a linear pair and it is supplementary with each other, angle 5 and angle 6. So let's take this x equals 11 and plug it back in all the way up here for 12x plus 13 to find the measurement of angle 6. Okay, good. So when you substitute in 11 for x, the measurement of angle 6 is equal to 145 degrees. So then I can use the information that angle 6, I'm going to label it in my diagram also, is 145 degrees with the information that angle 5 is dun, 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 7y, and I should be able to set up an equation that I can use to solve for y. What would that equation look like? All right, and so the equation is going to add those two angles together. So I'm going to use 7y, which was angle 5, plus 145 degrees, and that should add up to 180 degrees since that is a linear pair. All right, solve for y. So y, after some little algebraic steps there, is equal to 5. Okay, and again, not quite to where I know the angle measurement for 8, but I'm really super close. So I have x and I have y. Now, I do know already that the measurement of angle 6 here is 145 degrees. And if I just switch lines and I think about 6 and 8 right here being a linear pair as well, then 6 and 8 are going to add up to 180 degrees. And so that must mean that the measurement of angle 8 is what? Good. The measurement of angle 8 is 35 degrees. And another way we could have also found that out is by taking y, or well, yeah, y equals 5, substituting that back in for the measurement of angle 5. 7 times 5 is 35. And if I knew that over here angle 5 was 35 degrees, then I also know that its vertical angle, which is angle 8, is also going to be 35 degrees. Lots of really super awesome connections within these pictures. So hopefully that helps you get started on the worksheet for this week, and then we will meet live to talk about all of the things that you have questions about. Don't hesitate to send me a remind message or reach out to me in Google Classroom if you need any help. Thanks, guys.